All right. So yes, thank you everyone for joining us today. Big presentation. We are going to head and get started here on hot dip galvanized steel bridges and how to build that, that long design life, that sustainable design life that everyone's looking for in today's bridge market. So we'll go over protecting steel bridges with hot dip galvanizing. We'll talk about the life cycle cost, durability, sustainability, and a lot more than that. We'll also include some case studies towards the end. And then you guys, before I get too hot and heavy here, everyone will get an email within the next 24 hours with a certificate of attendance, as well as a link to today's slides. The slides are interactive as well. So every time we have a picture or you see that mouse icon, it either is a case study, a publication, one of our resources online, something like that. So it's really interactive. So be checking out for that email. If you don't see it for some reason, do check your spam folder. We've been getting caught by some spam filters. All right, so just a little bit about the AGA. We are the American Galvanizers Association. We've actually been around since established in 1933, so coming up on 100 years. We provide technical and marketing and I'm sorry, we provide technical expertise for everything after fabrication, hot dip galvanizing industry. So that includes design, inspection, specification, and everything in between. We also provide marketing and sales support for the voice of the industry. And then we're a free resource for North American specifiers. So if you're ever working on a project, you have a question about galvanized steel, either early in the design process or in use, you definitely reach out and let us know. We want to know what you guys are working on, and we're a free resource for you guys, almost like customer service for galvanizing. We represent over 170 different hot dip galvanizing plants, and over 76 companies are part of the AGA. It's all the way Canada, US, and Mexico, and then we're starting to expand into Latin America as well. All right, so first and foremost, why do we coat galvanized steel, or why do we coat bare steel with zinc? Well, it's that low life cycle cost. When you galvanize something, it enables that 100-year bridge design for sustainable infrastructure. That Mario M. Como bridge, even though it's a lot of concrete, they still designed a 100-year design life, and they used all galvanized rebar in that. It's just proven history in bridge applications. So it might not be the whole bridge, but it's all the bridge applicants that can be galvanized. Will give it that long life, that longevity, in some of the harshest conditions out there. It's very durable. It has that abrasion resistance. The alloy layers, the zinc and the metallurgical bond that it has between the steel, it's actually harder than the base steel itself. So it really gives it that extra abrasion resistance, either in install or while it's in use. And it also has minimal upkeep. Really, touch up and repair is very minimal. Usually, sometimes in the harshest environments, it'll go 70 years before you'll see 5% rusting of the steel surface. And this is off of all real world data. Galvanizing has been around for 150 years, only continues to get better. So, we have a wealth of information to go off of, a world of or data all around the world to go off of the last 100 years. And suitable for most bridge applications, including the superstructure, down to reinforcing steel, guardrail, sign structures, even buried structures. It does well in soil, even over, harsh water conditions and stuff like that. It's sustainable. Zinc and is and steel are naturally occurring abundant materials. Zinc is 100% recyclable without any loss of properties, including iron. So if the galvanized steel hits the end of life, it can be completely recycled, both the iron and zinc, 100% without any loss of properties. Truly a cradle to cradle material. It's available pretty much everywhere, 180 plus hot dip galvanizing plants in North America. We'll show you later. We have a galvanizer locator that'll let you look up the galvanizer near you in your area. Average kettle feet or average kettle size is 40 feet in length, 8 feet deep, and 6 feet wide. If the piece is bigger than that, I'll show later how we can do what is called a progressive dip, where it's you dip one side and then flip it around and dip the other side. You can do it all the way from small parts, fasteners, all the way to large structural members can all be galvanized. Quick turnaround time. It's factory controlled. There's no humidity requirements or curing. So there's some other coating systems out there that require certain humidity or a curing time. Galvanizing is neither. Once that piece is cool enough to be touched, it's cool enough to be erected that same day. Optimizations available to improve turnaround time as well if you're really needing that part fast. Aesthetics, it has that gray natural finish that blends in to its surroundings. Once it weathers, it's a neutral matte gray patina. So the zinc patina that develops over naturally weathering cycles, usually anywhere from about 6 months to a year. It'll all weather out. So sometimes you'll see a piece that's maybe shiny and dull on the same piece that's freshly galvanized. That'll all weather out to that matte gray as soon as that patina develops over that wet and dry cycles. Duplex system, though, can be offered for a little bit of color or added protection. That's hot tip galvanizing plus paint or powder coat. And then it just obviously offers endless aesthetic options. Plus, you get a synergistic effect where the galvanized steel is actually going to protect the paint or powder coat from underfilm or bubbling. And then, of course, the paint is going to, help isolate corrosion from the galvanizing as well. So synergistic effect between the two of them. All right, so I'll go in depth on some AGA tools and resources. These are just essential resources for specifying hot dip galvanized steel bridges. So first and foremost, our website is absolutely chock full. I mean, there's over 1,000 different pages. We have case studies about every single different environment you can think of, different size bridge you can think of, from big to small. Everything is very well organized. Everything is up top. So really, tools and resources, knowledge base, education resources are all going to be kind of separated out at the very top. And then our robust search function. So our search, it tries to guess what you're talking. It's powered by AI, and it does a great job. So it will actually bring up the top results, just typing in a random question even. So please use our website, bookmark it, and come back to it. There's chock full of information. If you do have any questions, feel free to reach out. But one section is our Dr. Galv knowledge base. Now, this is more than 400 short form Q&A articles. These are off of questions that we have received as the AGA, from the time it's existed, from the time the internet has started till now. So it's a collection organized by category. It's easily visible using the search function. It goes into the process of hot dip galvanizing all the way to EHS, environmental health and safety stuff. It's designed to answer specific FAQs about anything about galvanizing. It's tailored toward galvanizers, but also tailored towards specifiers when specifying or working with galvanizing, whether it be early in the design process or late inspecting galvanizing as well. We have a wealth of information. It all starts with those FAQs. Our Dr. Galv, who works on site, she's our technical director, Elena Fossa, and she is, pretty much the guru in galvanized steel. So we've created this whole section for Dr. Galv to pretty much answer all the questions that we get as the AGA. Now, when we do get questions, we get some pretty interesting questions every once in a while, but there's no silly questions to us. So everything gets researched. If we don't have the answer right off a hand, we're going to go contact the experts in the field. We're going to we even might even research a potential research topic, an issue, and turn your question into a case study. So the AGA is willing to help you guys out. Just reach out with any question, whether it be completely silly, like we had one that somebody bought a zinc plated trash can from Home Depot and wanted to smoke some meat in it. Those are the kind of questions that we get. And nothing's too silly. So we researched about, is food safe for galvanizing and, stuff like that. And we have a whole article on it on our website. So please encourage yourselves to reach out to us. All right, we also have a lot of design considerations. Part of our knowledge base is about designing for hot tip galvanizing, proper venting and drainage, you're thinking about how that piece of steel is going to move throughout the plant. So, you have to do, are they using chains or wires to pick up, the cranes? All of this is kind of summarized and buttoned up in the AGA resources we have. So we have a design guide. It's a full 30-page PDF. You can download for free or you can order a hard copy. And it goes over common fabrications, vent and drain hole locations, sizing, welding, before and after, masking, anything designing for hot dip galvanizing can be found in our design guide. The design poster is really neat. You can order it and just kind of hang it up on your wall. It has those common, common applications where venting and drainage or design is absolutely critical for the success of the hot dip galvanizing coating. Once again, these are all available on our website. I highly recommend that design poster. I, reference it all the time. All right. Along with our galvanized.org website, we came out with a couple years back with the BIL law, the Bipartisan Infrastructure Law Act that was passed. And finally, we are starting to see projects started the last year or so, and where the money's going. So we created a website. It's markets.galvanized.org. And this is highlighting hot tip galvanizing projects, but it also organizes it by market, product, type, state, and province. And it's all related to the BIL. So it shows where the money's going, how much money your state's getting, certain projects. And it also has animations that highlight various uses of the hot tip galvanized steel in these various markets. So say if we, drill down to highway and bridges and we want to look up, okay, what are components that can be galvanized within a short span bridge? This animation, each of the blue components are something that can be galvanized. And then when you're on the website, you can click into those blue ones and it explains more what they are, what benefit it is used to galvanize and so forth. So really cool interactive website, a lot of cool animations, and then a lot of information that you might not get anywhere else. That's all gathered in a really nice platform. You look up your state, you see all the information for the BIL, and certain animations and stuff. All right, a lot of people, think like, oh, you have to either choose all concrete or all galvanizing or all paint or, something like that. But actually, there are a ton of galvanizable steel bridge components. We put that in air quotes. Anything from the superstructure down to all the fasteners and small parts. Base plates, beams, cross bracings, joints, girders, all can be galvanized. Even those huge, 50-foot girders can be galvanized with, we can do a progressive dip, which is dipping one side and flipping around and dipping the other side, which we'll go into a little bit further later. But once again, there's a lot more that can be galvanized on just a simple bridge than maybe people realize. All right. With hot dip galvanized steel, we talk a lot about the longevity. How do we know it lasts, 70, 100 years in some of the harshest environments? Well, it's all off of real world data. We don't rely on salt spray testing. That's incredibly important because salt spray testing does not allow the zinc patina to develop. The zinc patina, which is zinc carbonate that builds up on the surface when the zinc coating goes through wet and dry cycles, and that forms almost a permeate or semi or non-permeable surface to really isolate that corrosion. So that's what really gives it that longevity. When you put a galvanized piece in salt spray test, it's consistently hit, so it doesn't allow that zinc patina to develop in order to give it that long life. So you'll see if it's a salt spray tested, it might be relatively the same results as a three coating paint or some similar system. But you have to remember that's because the zinc patina wasn't allowed to develop like it would be anywhere else in the world. So we created the zinc coating life predictor. Now, this is an extensive neural network of technology, extensive worldwide collection of database. And then we also worked with Dr. Gregory Zhang, who's huge in the corrosion world, to develop this time to first maintenance chart, the zinc coating life predictor, to really help educate the public about how long galvanized steel can really truly last. You can find it at zclp.galvanize.org. I will go into it a little bit more. So when you put in all the corrosion data points, for worldwide, um, and you come up with the time to first maintenance chart. It's important to know time to first maintenance is defined as 5% rusting of the steel surface, so still very minimal rusting. Average of thickness of zinc in mils is on your x-axis, and years and time to first maintenance is on your y. Average of think in average of mils of zinc on a piece, according to ASTM, A123 has to have at least 3.9 mils of zinc. Usually, it's typically higher than that, about 5 to 6 mils on a piece. But let's just say 4 mils is a good estimate for any structural piece. And say we're building an industrial environment, maybe a C3, a pretty harsh environment because of all the emissions. And we're still looking about 75 years before 5% rusting of the steel surface. Very well could be we get out there at year 75 and not see any rusting of the steel surface or less than 5%. Could be at the end of life, 75 years, that's a long design life. Could be time to take it down, strip, recycle, and reuse 100% of it because it's recycled without any loss of properties. Once again, it just gives you real world applications of how long galvanized steel actually lasts. In soil, it's harder to predict than in the environment just because there's highly varying properties within soil. Sometimes you're working with a clay-like soil on one side of the road and maybe a rocky soil on the other. So you have to account for everything, and that's why you just lean on us, the AGA, because we have actually created these soil charts for you guys. Free of use, you could just download them from our website. Once you find the primary and secondary factors of in your soil, which includes chlorides, your moisture level, and what pH is there. Once you find out that, you find out what chart you're working on. So let's say we're working a high pH, a low chloride, we'd be on chart 3. Anything in the red is less favorable. Anything in the green is more favorable for steel. Still, about 4 mils is a good estimate. That's over 70 years and still it's a harsh life. So once again, feel free to use these on our website, but once again, they're all off of real world data to go off of and can give you some real good guidance when working with hot dip galvanizing in soil. All right, life cycle cost calculator. Everybody always wants to know, well, longevity and everything. How does that equate to how much money I'm saving? How does that equate to the dollar signs? Well, that's why we have the life cycle cost calculator. Now, life cycle cost calculator is to ASTM A10 A68, but this is going to be the total cost throughout the project life. This is including maintenance, time, and value of money and interest and inflation. Often, when you're running these calculations, you can run as many as you want. It gives you a nice PDF printout. Often, you'll see that hot tip galvanizing initial cost is its life cycle cost, just because there's no maintenance required. Especially if it's, under 50, 60 years, definitely going to be no maintenance required. So I highly encourage everybody. I'll kind of show you the inputs and we'll run through one kind of but I highly recommend everybody popping over. You can find this at lccc.galvanize.org or just follow the link when you get the PDF or when you get the slide deck here. All right, so life cycle cost inputs include material and number of coats, surface prep, cleaning methods, if it's in the shop or field, 50 or how many square feet is your project? Is it a typical mix of sizes and shapes? Life cycle cost parameters are unique to that particular cycle. We use analysis considers the net present value and net future value, so interest and inflation. And then we went off of all the paint stuff for KTA taters dictated by the manufacturer. But there's a ton of stuff you can do for each project that you're working on. And then it will give you a cost comparison report. So initial cost for hot dip galvanizing versus a paint system, life cycle cost, and then what is its per square feet. Kind of goes through in detail. You can even have it email it to yourself as well. Very powerful tool, especially when you're, in between choosing on a coding system or, thinking about longevity more than just upfront cost. All right, I'll talk a little bit about this next section, just about structural design, a couple of steel types and sizes, just stuff to kind of keep in mind when designing for hot dip galvanizing. So material considerations, we get this question a ton, galvanizing temperature, we're heating that steel up to 830 degrees. What does that do to its properties? Well, we can tell you without a doubt, it does not change any of the steel's properties. It doesn't change the chemistry, the tensile strength, the yield strength, or microstructure of the steel. Now, if you have a highly worked steel, so highly cold work steel, you are introducing a lot of bends. You're introducing a lot of stresses within those steels. That some of those assemblies might be a little bit more on the side of warpage and distortion when you do heat them up because you're relieving some of those stresses. And we know that, steel wants to get back to its original shape when it's heated up. So just keep that in mind when you're severe cold working. High tensile strength, anything over 150 KSI. Risk of it, hydrogen embrittlement, but you definitely want to use alternate surface preparation methods and consult with ASTM A143. Another consideration is, how does the material move throughout the plant? Is it, hoists? Is it cranes? Are they using baskets for small items? A lot of questions is just have in the back of your mind when talking to a galvanizer to know, maybe ensuring the design capability is with, what they have available at their plant. Sometimes it's easier to design in modules and then fit in a kettle size and then, connect them afterwards. Or you can do a progressive dip, which we'll go into after this, for larger items over, 50, 60 feet. You also want to know about the weight. How big are these large items? Does the weight exceed the max load capacity of the handling equipment is another consideration. All right, so progressive dipping and just, it's dependent upon the project, obviously, if you're using these long beams that might not fit in the kettle. We do have a ton of information for you. So highly recommend, when you decide that, okay, we want to galvanize, but these pieces might be too big, pop on over to our website and I'll show you the information you can find. But progressive dipping is dependent upon kettle dimensions, part dimensions, and then material handling capabilities. And you want to manage expectations. There's going to be that overlap line because if you think right in the middle, might get 2 times the dip, so that might have a little bit thicker and a little bit overlap line if you see on the other one. That's just because of the uneven heating and cooling. You're heating one part up to 830 degrees Fahrenheit while the other part stays ambient. And it just increases that susceptible to relieve that stresses it within the steel and warp. So you just want to have an additional conversation with your galvanizer. Then pop over to our website and look up progressive dip. We have a whole page dedicated to it. But we have progressive dip charts. So it kind of shows you where your piece is. You measure it and find out, if it's possible. We have Galvanizer locator actually includes their kettle dimensions. So you can see how big they're working with, and then if it'll fit the size that you need. Then we actually have a progressive dip calculator. So you go put in enter your kettle dimensions and then the article dimensions, and then it'll show you if it's possible it can be fully galvanized or not. So definitely worth checking out if you're working with those extra large, steel beams. This is a Jessup bridge. This was actually installed back in 2013, and this was in Iowa, Jessup, Iowa. And initial, progressive dip lines were very dark in appearance. You can definitely see maybe a little bit rougher texture in 2013. About after 10 years, just obviously weathering, it has weathered out. You don't really see it unless you're looking for it, if that makes sense. It all weathers out to that matte gray color. A lot of times it'll even weather out more, even sooner, just depending on the type of environment. And so if you have just an incredibly long span and maybe not progressive dipping is not a possibility, we have what is called a hybrid zinc coating system. So it's hot dip galvanizing and thinks thermal spray, so or metallizing for mixed projects. So you can do the zinc thermal spray for the large inaccessible steel articles that will not fit in the kettle, and then the hot dip galvanizing steel articles that everything else that will fit. And since they're both zinc coatings, they're going to work really well together. This maximizes the cost efficiency because you can keep the cost lower while galvanizing, because zinc thermal spray can be expensive. And then you leverage the spirit protection of both zinc coatings. Zinc coatings love other zinc coatings. So galvanize smaller components, obviously, as well. And then everything is coated within a zinc coating. And I will highlight later, we just came out with a new publication on hybrid zinc coatings that is available to download for free. I like to mention our YouTube channel as well. We are starting to get more and more videos. We run a galvanized steel study videos, and these are all videos of 10 years in service of popular study or popular projects that we have done in the past. And then we talk to the architects and engineers 10 years later about, what they think and, if they've used galvanized steel again and, how it's performed. Really interesting stuff. We just finished one up about the snow bugs in Utah. It's pretty cool. Working on another one coming out. All right, get a ton of inspection questions about inspecting hot tip galvanized steel. We have a wealth of information. Usually all steel is going to be inspected, just verify conformance to specifications, ASTM, and usually a visual inspection with the naked eye or the unmagnified eye. And, just making sure there's no visible bare spots, drips, runs, spikes, anything like that. Coating thickness is and checked by a magnetic thickness gauge. And then we have a whole publication, visual guide of surface conditions of inspecting steel, galvanized steel. We have our online inspection course, which is becoming vastly popular. You get a inspection certificate right there, and then you get listed on our AGA inspector listings. So very cool. It's all free of charge as well. And then we do have a free inspection app, both for Apple and Google. It's available galvanized.org/mobile. And what's nice about that is once you download the app, it's fully available on your phone without any service. So if you're out on the job site in the boonies, you still have access to all of your the full app and the visual guide to surface conditions of galvanized steel. All right. We have more than 40 publications available online now. But just keeps growing, which is great, but here are some the main ones. We have a bridge specific publication, so it just goes over bridge specs. Steel bridges, a practical design guide. I'll show later. Hot dip galvanized reinforcing steel. So a lot of times, a lot of those bigger bridges will require concrete, but we go over how it's important to protect the reinforcing steel, the rebar, that can actually protect the concrete and have a better bond strength. Duplex system I mentioned earlier was just paint or powder coat over galvanized steel. Can be done for aesthetic reasons or super harsh climate. You see a lot of times like right off of the coast, get that added protection. Inspection of steel products we just looked at, and then hot dip galvanizing for sustainable development, which goes into all the sustainable aspects of galvanized steel. All right. Of course, you're on, kind of one of those a Galvanized seminar. This is a joint seminar with the SSSBA, but AGA puts on their own Galvanized seminars about 2 to 4 times a month. It's a live webinar with a AGA staff member presenting, and then we also have a live Q&A at the end. Everything is always going to be updated at galvanized.org/webinar. So if we'll just always have our next 3 or 4 courses available there. If we don't have a live webinar or you missed one, we have over 12 different courses that are on demand, and you can still earn a certificate and CE credit when you take a short test after on-demand course. So definitely check that out. And then Lunch and Learn. If you're in the US or Canada, you can submit a form on our website, and then we'll be in touch with you, and we'll send out a AGA member along with free lunch to give one of these seminars to you. I just want to go over a little bit of our collaboration and collective efforts for partnering organizations, and then we'll get back into our bit more bridge stuff. So I want to give out a shout out to the SSSBA, the Short Span Steel Bridge Alliance. They were established in 2012. They are a collection of people from AISI, NSBA, professors, bridge manufacturers, county engineers, everybody involved in short span steel bridges. Their target were bridges up to 140 feet, and they work with the local off systems of bridges. And, they do have some size limitations and headaches, but that's where we can kind of come in and help. And then they, also have some very new systems with the press brake tub girder and folded plate. And often, galvanized is, maybe their preferred solution in some of these. I also have the rebar focus group. This is a whole AGA subcommittee focused on just growing their rebar market. We have galvanizedrebar.com, and that has a wealth of information. A lot of times people don't think concrete's going to protect the galvanize or the rebar. Why do I need to coat it? It actually shows that galvanized rebar will protect the concrete from outgassing, sprawling, cracking, that sort of thing. The corrosion byproducts of galvanized steel is actually smaller than the iron corrosion byproducts and will plug holes in the concrete instead of actually pushing them and spreading those apart. So a lot of very cool, aspects of galvanized rebar that people don't really realize. So we dedicated this group towards it. It has performance, mechanical properties, field handling, standards, case studies, publications, and FAQs. So definitely check it out if you want more information about galvanized rebar. All right, so we got some other bridge resources. They are we have a bridge design guide, which is in English. It kind of mirrors the NSBA guide on, weathering steel. And then we also have a translation to Spanish pending for more of our members. We're starting to get more and more Spanish resources available out there. Some of our most popular publications are now being translated into Spanish. Some of our popular courses as well as being translated into Spanish. All right, like I mentioned, here is the Hot Tip Galvanizing Steel Bridge Design Guide. This is a full, over 30 pages, very technical heavy design considerations, best practices, performance expectations, maintenance strategies, everything you need to know for galvanized steel bridges. This is a great thing to order and then just, have on your desk as a reference, as kind of a handbook. Intended for engineers, owners, fabricators, detailers, just as a trusted go-to resource for hot tip galvanizing in the bridge applications. So once again, there's a link on here to download it once you get the email. I mentioned this a little bit earlier, but that's the hybrid zinc coatings guide. We're introducing this into the market as to help specifiers effectively combine hot dip galvanizing and zinc thermal spray on a bridge project. A lot of times I think there's been kind of a misnomer in the past that, when you specify something, you have to have it all of one coating system or all of one something. And this is a kind of mixing best of both worlds. And we know that both zinc coatings are going to work well together. This includes real world case studies that's already demonstrating a successful hybrid coating application in the world today. All right, I'm going to just kind of wrap this up a little bit. I wanted to give a couple case studies, maybe some of the more recent ones that we helped out on. But this is the Missouri Department of Transportation, MoDOT. They decided that they needed to fix over 31, they needed to replace 31 bridges including 27 steel supported structures throughout their county. Um, Budget of 26 million, and they all were replaced with weight restricted, supported by timber piles in poor conditions. Maybe one lane actually carrying two lanes of traffic. So really, just they needed updates. So they decided to replace all of them with galvanized steel. They wanted to do they really adopted the simple for dead and or simple for dead load and simple for live load design method, which Dr. Barker has actually highlighted in a couple of his past presentations, and we've done one as well. But we go more into detail. There's a link there about our case study, but it's great because it's obviously going to keep costs down, keep maintenance down for over 31 bridges throughout the county. This is the Fort Wingate Bridge replacement in New Mexico, and this is one that I had mentioned earlier too about the press brake tub girder system, a U-beam. It boasts that it's a 75-year expected life. It's all galvanized, and then it's kind of a plug and play system where they come and put the bolts on, and then the deck lays on top. So really, they can all get this done within about 12-hour turnaround time, which is great for these short span steel bridges. Sometimes you're working on a large bridge, and I like to throw a shout out to some rebar, galvanized rebar. Mario M. Como Bridge. If you live in New York, you've probably driven past it or driven over it a few times. 3.1 twin span. The New York the DOT and the State Highway Authority really wanted a 100-year design life. So they decided to galvanize every component that they could. And that included 59,000 tons of rebar. So I had over 8 members all work on it. But a huge project, but that galvanized rebar is actually going to protect that concrete, and hopefully give it that 100-year design life. All right, this is the Stearns Bayou Bridge. This is in Michigan. This is the first fully hot dip galvanized bridge in the United States, 1966. We went back and it was inspected in 1991 after 25 years, and then back in 2017 after 51 years. And there was still an average of 3.3 mils of zinc of coating across the bridge. So kind of gives you a real life example that's still in use today, over 50 years, and has still got over 3 mils of zinc left. So plenty of corrosion time left. So this will probably last another 50 years if I had to guess. All right, so then in summary, AGA is the trusted resource for bridge design projects. If you want to any more information, there's our information up there. You can email us, reach out social media. There's our website.